I want to talk about the periodic table, and how the periodic table was formed, how it came to be. All right? And there are some ideas on how the periodic table worked. And the first thing you need to know is that people were able to identify certain elements. Okay? These elements, each one had their own physical properties, how they behaved, what their mass was. They had discovered a lot of this information already. Okay? The first guy who came up with some information was John Newlands. And what he did was looking at lower mass elements. He was able to determine that some lower mass elements would repeat what their properties were every 8 elements. And this was back in the 18th century. Newlands discovered that there was a law of octaves, which worked great until you got up to calcium, and then beyond calcium, everything started falling apart. So, a lot of people really badmouth Newlands. I guess he probably had, when that happens, there's usually some sort of personality complex go along with it. Newlands was gradually dismissed with his law of octaves, but he was on the right track. Okay. Call in Dmitri Mendeleev and Lothar Meyer. Okay, and I hate to do this, Lothar, but for the most part, Mendeleev, came up with the modern periodic table. What he did is he began to lump these together, lump the elements together by their properties, similar to what Newlands did, but he was able to look at these things, lump them up by properties, and start developing a table by what was known. This is the origin or the origins of the periodic table. Okay? And when we look at a periodic table, and I'll draw out a simple periodic table here. Okay? Come up here, do this. Alright, so this is a periodic table, hopefully. Okay. And in the periodic table, remember what I said about what the elements are. And this is the S block over here. So in column 1 and column 2, these two things belong to the S block. This is where the S electrons all get filled up. Okay? In the S block, they all have similar properties. Okay? Now, in this case, hydrogen and helium are 1 and 2 here on this pretend periodic table. But it should be noted that helium doesn't have the properties of anything else that's in the second row. So for the most part, I'm going to ignore helium, even though technically it's in an S block. Okay? Helium belongs more over in this range. So I'll put this over here. So here's helium, and I'll put hydrogen there as well, because strangely enough, hydrogen has properties that are similar to a lot of the elements that are over here in this particular row. So let me write this out. 3, 4, 5, 6. I hope I give myself enough space. 7, 8, 9, 10, 11, 12. Oh, look at that! And I can tell right now I don't have nearly enough space for the P block. Let's try it anyway. So 13, 14, 15, 16, 17, and 18 over here. Okay? Okay. So, elements 18 and down in the 18th column all have similar properties. And 13 through 18, all of these are the P block. Okay? The P block is all in that range. Now 3 through 12, that's a different block altogether. And that block is called the D block. And then down here in the bottom, there's the F block as well. I'm not even going to fill these guys in. I'll just write F block here. Okay. Now, what I would invite you to do is open up a periodic table and take a look at it and try to follow along with what I'm doing here on this table. We've seen the D block, S block, D block, and P block. And everything in these columns, all of these columns, they exhibit similar functions. Okay, all of these are kind of related. So if you look at lithium, this is over here, there's lithium, all right? And then we go to sodium, and then there's potassium over here, and then there's it's rubidium, Rb, no, cesium first, and then rubidium. Ce, that's cerium, cesium is Cs, Rb, and then francium is down here as well. All of these elements on the periodic table, all of them exhibit similar properties, okay? And as a result, we look at these and we say, since these all exhibit similar properties, these are all alkali metals. Okay? All the alkali metals exhibit similar properties. Anything that's in this block, we start with beryllium, and then there's calcium, magnesium, calcium, selenium, no, not selenium, strontium, barium, and radium. Okay? All of these in this block, and did I just notice something? I was right when I started with it. I reversed rubidium and cesium. Sorry about that, folks. I'll fix that now. There's probably somebody out there who's watching the internet right now very angry. How dare you do that? You call yourself a PhD. Well, here in the second row, or excuse me, second column. In the second column here, these things are called the alkali earth metals. Alkali earth metals are all in that particular column, okay? In this D block, here in this region, there are some metals that are there. The precious metals are there. We've got silver, we've got gold, we've got platinum, we've got copper, okay? Those tend to fall into the precious metals category. There's some with similar properties, okay? Zinc is one of those that has similar properties, and strangely enough, it's very similar to cadmium and mercury, okay? All of those exhibit very similar properties. Okay? But for the most part, I'm not going to identify those groups in the transition metals as anything other than transition metals just yet. Because you can study this for a very long time. The transition metals are fascinating and frustrating at the same point. The world of inorganic chemistry is all about people trying to figure out what we can do with the abundance of these metals that we've got. And if you know anything about solar cells, one of them is indium. Indium is one of these metals that when you dope a piece of glassware with it, it helps bridge the gap that you get with the glass, and it makes it a very good transmitter of electricity for photovoltaic cells. Before we were doing indium, we were using tin, which was not nearly as good. But indium actually works very well. Okay, and that's over here in the transition metals. Why does it work? Well, you have to take inorganic chemistry to figure that out. It's an interesting field. It's very, very popular right now with the advent of solar chemistry. All right. Now over here, I've already discussed what these are. These are the noble gases. The noble gases are over here in the column 18. All right. They're unreactive to anything else. They're also monoatomic gases. You find them in lights, in neon signs, that type of thing. All right? In 17, you have the halogens. Halogens are necessary for life, but they can be quite dangerous. You breathe chlorine gas and you die, but if you don't have HCl in your stomach, you can't digest anything. Right? Useful things to have around. All right? In this column, these are oxygen similar compounds. Oxygen's in 16. You also have sulfur. Okay. 15, you have nitrogen and phosphorus, two elements that are vital for biological function. If you know anything about ATP or nicotine that's in your body, and yes, even if you don't smoke, there's a certain amount of nicotine in your body. Okay, those materials are vital to what you do with your body in order to try to get energy out. Okay, so you need a lot of nitrogen in your body. You need a lot of phosphorus in your body as well. Over here, row 14, my favorite element, carbon is in there. Carbon, you've also got silicon, right? And over here in 5, aluminum is there. Okay, you can make tinfoil hats out of it, and prevent people from reading your mind, that type of thing. Okay? I don't know if it works. Don't ask me that. Okay. You frighten me, people talking to your computer. All right. So over here, we've got a certain dividing line. And it starts with boron, and it kind of comes down here. It starts with boron, and then you've got carbon here, and you've got silicon, and this line that is drawn throughout the periodic table, it kind of follows a staircase line, and it goes to, you got germanium over here, and I guess that's considered one now. And this line kind of walks like this through it. And there are certain elements that are comprised inside of this box line that you see. You can see this on the inside cover of your book if you look at it. And this particular box represents things that are called metalloids. Metalloids are elements that have metal character and non-metal character. Okay? Now, everything over here, everything I've got listed over here, over on this side, and anything that's down here, you find lead down here, and arsenic and some other fun things. Tin is in this region. These are metals as well. Okay? And these are P block metals. They're in the P block, but they exhibit metallic qualities as well. And anything that's above the metalloid line, anything that's up here, these things are called nonmetals. What are nonmetals? Well, they're not metals, right? Carbon, oxygen, nitrogen. The halogens are considered nonmetals. All the noble gases are considered nonmetals as well. Hydrogen is considered a nonmetal. Okay? So that's why hydrogen shows up here in column 17 on some periodic tables, is because hydrogen really has the properties of halogens more than it does the alkali metals, even though it has some reactivity similar to that of the alkali metals as well. All right? So this is everything that you need to know basically about a periodic table. You need to know how that everything that's in certain columns, these things, they're families that are going to react in similar ways. All right, look at some of the videos that I attached to this video that are nice follow-ups to it. One of them comes from a show called Brainiac, and it shows you probably might have seen this in high school, where they blow up various things using alkali metals. There's also different halogens. All the noble gases react in a very similar fashion. A lot of the halogens do as well. Okay? I'll see what I can find as far as videos, and just so you can sort of visualize how these things, all of them, sort of react in similar fashions. But let's look at some more periodic trends while we're at it, because that's what this particular talk is all about.